Here is our first example of using expected values. Now, this is a very simple example, basically just showing more of how to do expected values and what we can do with it, like how we can use expected values to take our categorical data and make it act a lot like quantitative data. So here we go. We've got a probability distribution of categories 0 through 4. So there are 5 different categories along with their probabilities. We want to find the mean and the standard deviation. Now, the mean, not a problem. We just saw how to calculate the mean. We take each value, we multiply it by its probability, and add it up. But what about the standard deviation? There's the equation for that as well. We're not going to get into that, but I'll show you how to do it. Anyway, so here are our probabilities. There's a bar graph showing the probability distribution visually. Now, if we were to take all of these values, multiply them by their probabilities, you'd have 0 times 0.09, which of course is 0. Then you'd have 1 times 0.15, gives you 0.15. 2 times 0.4 gives you 0.8. 3 times 0.25 gives you 0.75. 4 times 0.11 gives you 0.44. You add all of those up, you get a total of 2.14. Okay, great. That's our expected value, also known as our mean. Now, how do we find the standard deviation? We're really not going to need this a whole lot in the course, but in this example, I wanted to show it to you because there's a very important thing we can do with this in just a second. So you could do this with any software. Since the TI-84 is commonly used in this course, we'll use that for this example. So we have our values, 0, 1, 2, 3, and 4. Those are our categories. I'm going to put my categories into a list. And then I'll have list 2, which will be the probabilities for each category. Okay, so I go into my TI-84, open up the data lists, and I edit the list so that I've got the categories and the probabilities in 2 separate columns. Well, then I hit the stat button and I move over to calculate and I select one variable statistics, option 1. This is what we did for our quantitative variables. But now there's one difference. Remember that before we would put our list that has our data in it, and we would leave that frequency list empty. Now that we're dealing with a probability distribution, we're going to put the probability list in that frequency list spot. Okay? So, essentially what we're doing is we're telling the calculator that list 1 has my categories or my values, and list 2 has the probabilities for each category. Then we hit calculate, and it gives us our one variable statistics. Okay, notice the mean. The mean is 2.14. That's exactly what we got for our expected value. Now, what's the standard deviation? Now, if you look closely, remember that we had sample standard deviation and population standard deviation. But here, the sample standard deviation is blank. There's nothing there. That's because when we deal with standard deviations of a probability distribution, we don't have to worry about these degrees of freedom. And so sample standard deviation goes away. It's just one standard deviation to describe the whole population. Anyway, if you read that, we get a standard deviation of 1.086. Woohoo, great, so what? Well, if I were to take my bar graph here on the right side of your page, on the right side of your page, there's that bar graph of my probability distribution. If I were to put on a normal distribution with a mean of 2.14 and a standard deviation of 1.86, I get that normal distribution right there. Pretty incredible how closely that fits, okay? So the expected value, or the mean, and the standard deviation of a probability distribution can be used to give us a normal distribution which we will use a lot in the second half of the course after the midterm. And so there's our connection. We have now taken a categorical variable and got numerical results that we can calculate numerically.